Welcome back, ladies and gentlemen. In this video, we are going to be diving into our vector talk once again, and we are going to be discussing specifically about the magnitude of a vector. Now, if you remember from our last video, we decided that the magnitude of a vector was just the size or the length of a vector. Now, remember, a vector has two components. It has magnitude and it has direction. And so we're going to be focusing on the magnitude of our vector. Now, remember, we talked a lot about representing a vector with this kind of lowercase bolded looking V that you see right through here. All right, you will also kind of see the vector written out in a more of a name form like you have right here using the initial point and the terminal point. And we can go ahead and find the vector or the length of it and going by with a kind of a brief little formula, and honestly, it should look very familiar to us that it's kind of our distance formula. And you notice the absolute value because direction is, or the length, excuse me, is always going to be positive. And so we're going to end up using this formula to find the length of a vector here. So what we can kind of do is, I don't know, in a sense, shorthand that. So that's what you see and broken down from this spot to this spot here. If ultimately, right, the magnitude of a vector is the change in x squared plus the change in y squared, all under that square root or our distance formula, ultimately what that ends up being is just taking our component form squared plus the other part of our component form squared, and keeping that all under the square root. Well, why? Because remember what we talked about already, that we can use that head minus tail rule to find what that component form actually is of that vector. Okay, so let's take a look. Find the magnitude of a vector. Find the magnitude of the vector represented by PQ, where P is -3, 4, and Q is -5, 2. So let's go ahead and find out what that component form is going to ultimately be. So I'm going to go ahead and just kind of look here right off the bat that the magnitude of our vector is going to be x2 minus x1 quantity squared. So if that's the case, our x2, Q is our terminal point, right? Q is our terminal point. So we're going to have a -5 minus a -3, which turns it positive, quantity squared, plus 2 minus 4 quantity squared for the change in y. That all is going to end up equaling the square root of 8. And let's simplify that guy on out a little bit. And we have 2 square root of 2. Now, you also can show this in component form. So remember, what we did underneath here is the component form of the vector. So by saying the -5 plus 3 being -2, that really meant that the vector PQ was also equal to the component form of -2, and then 2 minus 4 is also -2. So you could have started it either way. So notice this. I gave it to you using initial point and terminal point, or I could have given you the component form and you would have just went ahead and said, okay, well, then the magnitude would be -2 quantity squared plus -2 quantity squared also equals the square root of 8, which also equals 2 square root 2. So either way, you get the same result, just depending on what you're provided first.